Hello all, today in this video we are going to make an video for improving the validation accuracy of CNN. If you have noticed the previous video means we have made an heart disease prediction with CNN with Adam optimizer, and for that we got very less accuracy on no 96% accuracy, but for a better system when compared to validation accuracy the when compared to this I got confused. That is training accuracy, via validation accuracy should have some higher values, right? But previously, when we are working, if you have followed the previous video, means you would have known that in training of accuracy, will be only high. For that, we I just mentioned that we will make some steps to improve this validation accuracy. So for that we have made some steps how to improve this validation accuracy. So now we can make through it. So in the next video, still we don't have some better validation accuracy. Both are same or equal only. So in the next video we can make some better things to move with again improved validation accuracy. So for that initially we are importing the libraries which we are needed, and then this data set we downloaded from Kaggle. You can just give us hard disease data set. Kaggle means you will get this data set, and in the data set it will have nearly 14 entries. Among that the first 13 entries we will be using as the x variable, and the last entry we are using as the y variable. And we are getting the info of the data set. From that you can notice that only the whole peak is the float one, all others are integers. And then we are describing our data set, and we are getting any null values. It is having any null values. Since if it is having any null values means we have to work with some preprocessing function. Since our data set is not having null values, we have omitted that. Then we are counting the value counts of this data. By that we are just getting that how many zeros and how many ones are proportion of it is found. When compared to 0, one proportion is high. Then we are also making a plot. Then we are making a heat map. Then we are describing the x variable and y variable. As I said previously, the x variable we will be using as the first 13 attributes. So we are dropping the last target variable and using the all others as x variable, and in y we are using only the target variable. And by using this x variable and y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training. We are determining variables like x train, x test, y train and y test, and then we are using the standard scalar to conversion of vectors. By this we are applying two variables like x train and x test. Then we are getting the shape of x train, and when coming to CNN it will work with only three-dimensional data. So we have to reshape our data set. For that we are using the shape function and reshaping our data set. By that you can notice that initially the shape was 820 comma 13. Now it is 820 comma 13 comma 1. Then we are determining the layer contribution. First it is sequential layer, next comes the convolution layer, and within the convolution layer we are determining the other parameters like kernel and all. Then padding as same, activation as ReLU, the input shape here from here we have given as 13 comma 1. Pooling, max pooling 1D layer with the pool size of 2, then flatten layer, then dense layer with output dimension as 128 and activation as ReLU. Then a dropout with the dropout size of zero point 0.5, and then a final dense layer with the output dimension as 15 and activation as sigmoid. Why 1? Because this is the binary classification work. If we are working with multi-class classification work means we have to give the number of classes which we are having in the place of 1. Then we are getting the summary of our layer contribution. So this is the summary of our layer contribution. Then we are compiling our data, and then we are training that CNN model by using the fit function and the variables like x train, y train, validation data, and 50 approaches we are working for. So if you want to work with some improved approaches means you can just give it. up. So for 50 approaches, our model is running, and we have got an accuracy of validation accuracy of 9561 in the last approach. Then we are getting for that we are just plotting a model. Here you may notice that training accuracy is high when compared to validation accuracy. So this is the thing which we was previously seeing, and it has got an accuracy, precision, recall, F1 score, etc. And we are also plot the confusion matrix. Now we are going to improve this accuracy. The all the parameters we are using as same as in the previous model. The only thing we have changed is we are reduced the dropout size, that previously it is zero point 0.5 and now it is zero point 0.2. So if you just drag the video means you may notice. So now if you because the other all others are same. Optimizer is Adam on all others are same. We are working the model for nearly 50 approaches, and we have got an validation accuracy high, and you may notice when compared to accuracy, validation accuracy is high. And we have also displayed plotted it's a graph. So here you may notice the validation accuracy is high when compared to the training accuracy. So in this case we are just decreasing our dropout rate. Likewise, for every CNN model we have to try some either different combinations by using some trial and error method. Likewise, we can definitely got some better accuracy value. So in the next video we will be working with different optimizers, and also we will trying to further increase this accuracy. Thank you.